am super happy to be in Switzerland today with you for doing this virtual company visit. So maybe we can start, you can show us what is surrounding your company, just to start.
You are now virtually in Biel, which is a tiny town right in the center of the watchmaking valley, which makes this area particularly interesting. Our building is smaller, but at the same time, we are doing there a level of innovation which makes it bigger on the inside. This is the entrance of our office. But first, I want to show you a bit of the Swiss expertise and super high quality that you can find in the region. Sabato Microtech is our preferred partner for machining and prototyping and very high quality parts. And their production facility, as you can see, is probably one of the best you can find in the areas. They got milling machines, EDM manufacturing. They got their own metrology rooms. There's a lot of people working right now. This there is a 7-axis machine which we use to manufacture parts of our tooling. And also you can find EDM machine just here, which are very, very useful if you need to cut very fine feature with micrometric precision. So this is really a gem in the Swiss watchmaking valley for prototyping, for really high quality parts. There's also metrology, there's finishing rooms, polissage, which is the nice French word for surface finishing. And this, let's say, this really make our expertise stronger also in the micro manufacturing area. But now let's get to see what we do specifically, not just our partners. So I'll show you where the magic happens. Here, I want to welcome, this is our door, and I want to really welcome you inside of our office. People, there's movement, always people working. This is really a company visit. And first of all, apart from the tables, I want to show you our last creature, which is this machine. This machine is a contactless machine, which is specifically designed to do laser processing.
Tell us, what kind of company is Touchless Automation?
Touchless Automation is a very, let's say, high technology company. The idea of the contactless manipulation was done by Fabio, the CEO, which actually, unfortunately, today is not here because he's visiting a customer. And the idea was, when we were studying nanotechnology, some of the processes are very fragile. Some of the components just get destroyed just by looking at them, and people working with photonics know what I'm talking about. And so the idea was, how can we move things without touching them? And that's exactly what we did. So the company is based on this technology that uses a combination of ultrasound and vacuum to create a very stable levitation. So let me explain. The vacuum pulls the component up, and the ultrasound creates an air cushion between the manipulating tool and the component. And this allows the component to be really stable, but at the same time, never touched. The company was founded in 2016 here in Biel with the target of exploiting both this technology and our strong expertise in automation and micro manufacturing. And this, let's say, the company since then has grown. Now we have, let's say, you've seen the office, there's people working together with us. And we just recently hit some very important milestones. We just completed our first fully automatic machine, which is able to process laser diodes from tape. So you pick it up from the adhesive tape, you can do a whole inspection of the component. So top, bottom, front, back, every side. And in the end, deposit into the carrier, always without touching the very sensitive parts. If you deal with very, very high precision, high quality, and sensitive components, the fact that you are not touching them is really a plus.
What kind of motivation drove you to create a company developing such innovative technology?
Well, as you said, the technology is always the key point. So the idea is that both me and Fabio and everyone working in the company as high tech as their main motivation. So we wake up in the morning And we think that doing high technology stuff with very high precision and making, let's say, the impossible possible is what drives us. And we still remember the first meeting we were having when the technology was still very young. We had a meeting with the CTO of a very large company, a US-based Nasdaq-listed company. And when he saw this technology, he just jumped off his chair and said, "Okay, that's impossible. You're cheating. That's Photoshop." And actually, no, I mean, that was true. And actually, this company became our first customer just like some months after. And this, let's say, this continuous force that pushes us towards high tech, something which is difficult, something which is very, let's say, on the pushing the level of the state of the art for manufacturing is really what, let's say, what drives us every day.
Then tell me about the most challenging situation that you found when creating your company.
Absolutely. Challenges are, let's say, are present every day. The biggest challenge we had in the beginning was to control the technology. There was something new, there was something innovative. We were the only one doing that. So the real point was how to control this phenomena. And this was exactly what we did in the first year of our existence. Now we are able to control the levitation of each component with a precision of in the order of the microns. So we are really, really precise on that. And this, of course, unlocked new scenarios with new difficulties. The last difficulty we solved was to create a machine, and I will show you quite soon the machine, which was able to be reliable, industrially efficient, but at the same time still innovative enough to welcome our technology inside. And we solved this technology, let's say, let me show you the machine.
Yes, let's go.
So this is our newborn baby, as you can see here. And actually you will see just for a couple of weeks still, because we're going to deliver this to the customer in some weeks time. So this is the machine, our last effort.
Can you go? Yes, please go closer.
As you can see, it is equipped with the best of the technology you can find it around. Let me open the door for you. As you can see, in order to increase stability, we use a granite base. In order to provide very high precision, we use some of the best linear axes and linear actuators on the market. This machine has 5 different visual inspection systems. It has a dedicated die ejection also system. And all of this combined together is literally the result of the last effort we put in the last 6 months. There's a lot of machine makers in the world, but having something which is so precise, so custom designed for the customer, for instance, all these visual inspection systems were asked by them, is really something that puts us in a very good condition for the future. We think that a machine like this could really be helpful for a lot of our other applications. This one is for the laser diodes, but also we have customers which are asking us similar machine for optical filters, for lenses, for VCSELs, for image sensor. And this is really the future. We really see a wide range of application which might span from this first machine we did.
What is the customization that you can have with your technology? I mean, the distances that you can get your die up. Can you modulate these distances, or are fixed?
Absolutely. We can, as I was mentioning, we can control now every part of the technology. So we can modulate the gap between the tip of the tool and the component itself. We can also, let's say, manipulate components with very, very different shapes. We manipulated lenses which were concave, convex. We manipulated small MEMS, for instance, for infrared emitting surfaces. So the key point now is that the technology is really flexible enough to be accustomed to any particular application. And we are able to control the technology, we are able to build the environment, and putting these things together with expertise on machine vision, automation, we are able to build systems which are based on the machine you just saw. So this is the platform where we can integrate different processes. We're just developing a second machine, which is inspecting optical filters, and based on the platform I show you, we can do, for instance, a visual inspection that gets the light through the component, not just on the surface, so we can inspect even the inside if there's any crystal imperfection. We have vision that can check, for instance, if the physical shape of the component is fine, or even if the radiation emitted is in the right light let's say wavelength.
And what about parallelization of the process? Is just a single tip, or you can have more than one tip at the same time? I mean, more than one die at the same time being inspected with your system?
We actually got the request for this. We can do that. For instance, what we like to do together with the customer is to understand why they want to parallelize. For instance, for a customer, we didn't parallelize the pickup, so we didn't need two tips, but we were doing the inspection while a second component was picked up. So we just, let's say, we parallelize the process and not the hardware, which keeps, let's say, costs lower, but still increase a lot throughput and cycle time.
So what about the potential of the miniaturization of your components, of your hardware components? Will be this a value for you?
Yeah, actually, right now we are working on many concepts. This is one of them. Actually, another concept we are looking through is the quick exchange tip. So if you have components of different shapes, you can have a very quick exchange of the tool and manipulate. Use the same machine for many different component families. And that's the key point. One of our expertise is really to understand the process that the customer wants to have and to fit it into the machine. This is the key point.
And also, do you have some numbers about the percentage of failure when you are not using touchless technology in comparison with you are using your technology, no?
Yes, I cannot really disclose the numbers on each particular application because, confidentiality. But the point is that as soon as you remove the physical contact, you can even get certain sources of defect to zero. We had one project some months ago. I'm not going to say customer name or application, unfortunately, but on this project, we were able to get from 60% quality to 100%. So that's really something that we can do. But unfortunately, it mainly depends on the application. There's application where we really can do the difference, and others where we just, let's say, we are still very good, but on par with others.
You were talking about, yes, you cannot disclose these applications, okay, but give us an idea of what are the applications in which you think your technology is going to impact, maybe now or in the future. No, you can see maybe in 5 years' time.
Absolutely. The first one is really the laser diode market. Laser diodes, you are very expert on this, but the point is that laser diodes are delicate, especially high power laser diode sources. Even a small scratch, a small particle can create a critical optical defect when they're actually being operated. Because, for instance, a defect which is below 1 micron, just something so tiny that you would think it makes no difference. What happens when you flush this defect with a very high intensive power? This could create cracks and destroy completely the point. And our technology does not allow only for contactless manipulation. It's also the secondary effect, which are very important. So you don't touch, so you don't scratch. But at the same time, if you don't touch, you don't create any dust particle. So the tip always is perfect. It doesn't stick. Nothing is stick to the tip. So even the processes which are going to be done after the first component, so first component, second and third, they are always staying clean. There is no dust created. And this creates a process that is still at the same level of quality from the day 0 to the day 100. So which is also something which makes it more reliable. Let's say that the laser diode is really the market we're seeing the greatest application right now. But also, for instance, I was mentioning before the optical filters. Some filters are coated with multi-layers of coatings that allow for the selection of the right wavelength to be, let's say, to be filtered out or filtered in. And these layers can be very, very, very delicate. So sometimes some other machine producer just pick the filters by the sides, but even this approach can create issues. The key point is really to pick it up from the delicate area without hurting it in any way.
How do you think your product will evolve? Will go in the direction of a parallelization or maybe more integrated, well, able to be integrated in other bigger machines? So how do you see your product?
That's a very good question. There's many ways our company can evolve right now. Right now, we have found a niche which is super interesting in what we do because their volumes are still growing, but still they are not willing to compromise quality over quantity, which makes it perfect for our machine because we can really guarantee the level of quality which is even above, let's say, homemade components. But at the same time, it's automated. So one of our customers is telling us, okay, now the people in my clean room can really do something which is, let's say, value driven and not just spending days picking up the components and moving from place A to place B. We do that in a fraction of the time they are using that. And this is not just, let's say, our initial target, it's even the target for the midterms. We think there's a lot of industries which are still rely on lab-based, let's say, people to make their processes, while we could automate that with a level of quality which is even higher than that. For the future, we even see that we could integrate our technologies in other machines because our hope is that people will understand that not touching the components not only increases quality, but can also unlock new designs. For instance, a mug needs a handle to be, let's say, to be taken because otherwise you will get burned if there's a hot coffee inside. What if you don't need to touch the mug, you can get rid of the handle. And just imagine how this opportunity could mean if you are doing, for instance, CCD. You could have an image sensor which is just the size of the image sensor, and the context, not also, let's say, a passive area to being able to manipulate that. We could make ultra thin substrate. We could enable components with even weird geometries, because then if you think about, I don't need to think about the manipulation, I can be free, then the designers will be able to roam in a whole new world of opportunities for design.
How we can help you to get your goal? So what are your ideal customers? What are you expecting to improve from your suppliers? Yes, this kind of questions. How we can help you?
As I was mentioning, technology is really what keeps us awake at night. We're thinking about new opportunity, new solution. Honestly, we started from the watchmaking. That's say how the idea was born, and we found out about photonics also thanks to you. So the key point is always that we are looking for new applications of our technology. We know that it's working for sure for the laser diode, it's working for sure for the optical filters, for the lenses, but there's so many other components and technology that we don't know. And the key point for Epic, for instance, one of your biggest values is always putting together people that knows a lot about technology, making them talk and find out new opportunities. I think this is one of your biggest values, and this is really what we need, because we have a great technology. We know there's many technologies around that also need our help, and this is really something that can happen in the future.
Okay, thank you very much, Maurizio, for this super nice visit, this super nice conversation we just had. So yes, I think it's time for me to come back to my place in this virtual visit. So
me too. Let me leave the people working actually, because I think I disturbed them enough.
I'm sorry. Yes, I apologize.
Technology requires concentration.
Focus. Yes.
And let me say goodbye to you again in the sunny Swiss weather, which is, let's say, not exceptional, but the snow will come, and then, Switzerland will be great for other reasons than the sun.